Okay, so we're going to start again on fingerprinting. We looked at kind of what fingerprints were made up of, what the three main patterns were, loop, whirl, and arch. The arch has the tented arch as well as the normal arch. For the whirl, you've got central pocket whirl, you've got the normal whirl, you've got the double loop whirl, and you've got the accidental. And then for the loop, you've got a radial and an ulnar loop, depending on which hand it's from. So we know that fingerprinting is an individual characteristic, that it will allow you to narrow it down to one specific suspect. There are no two individuals that have the same fingerprints. Because the fingerprints come from the dermal papillae layer of the skin, they remain constant for life. As your skin reproduces, it reproduces on that layer that has those ridges, so the ridges are embedded into the skin as it grows. Basically, there are ridge patterns we talked about that allow the fingerprints to be classified and identified. So we've gone through some of this before. Remember, an arch, there's plain and there's tented. It enters one side, exits the other. If you're talking about a loop, it enters on one side, goes around and exits the same side. A loop always has one delta. If it opens towards the thumb, then it's a radial loop. If it opens towards the pinky, it is a radial, I said that twice. If it opens towards the thumb, it's a radial loop. If it opens towards the pinky, it's an ulnar loop. And then we have the whirl, and there's the plain, the central, the double loop, the accidental on the whirls. I'm having a hard time getting this to move. Okay, finally, now it's jumping. Okay, sorry about that. There is an FBI has a classification system where each number is given a point value. I'm not going to expect you to know how to calculate that. But we're not going to worry about that. So we talked about one of the issues is there is no real legal requirement in the United States as to the number of points necessary for a match. So generally in the criminal court system, we'll accept 8 to 12 points of similarity. So not only like the loop, the whirl, but the individual minutia, you need 8 to 12 of those to make an actual match. So we talked before about the structure of the skin and where necessarily the fingerprints came from. The dermal papillae, which is that layer that is the bridge between the dermis and the epidermis, is what forms the fingerprints. But we talked a little bit in class. In order to actually get a print left someplace, you have to actually have the glands give off the secretions that leave the marking on the surface. Because most fingerprints, well, all fingerprints are not going to be like ones that we did that are inked. They're usually partial prints that they use powder to lift. So in order for the print to be left on a surface, there has to be oil present or sweat. And so you have what are called sebaceous glands, and those are your oil glands, and they are attached to the hair follicles, and they produce oil once somebody hits adolescence. And then you have what are called your eccrine glands, and those are your sweat glands. So they release the sweat, which is made up of not only water, but salt, amino acids, also some of the waste products, urea and uric acid. So when we're talking about a latent prints are prints that are not visible to the naked eye. So in order to make those prints visible, you have to use some type of a powder in order to see it. The prints are made up or consist of secretions from your skin and require development in order to become visible. So most of the secretions that come on the surface of the skin come from three main types of glands. The first one is eccrine, and eccrine glands are the same things as your sweat glands. They secrete largely water, and they have like ammonia, chlorides, metals, and phosphates. They have organic matter like amino acids, lactic acid, and urea. And most of those are these are the ones out of sweat that are most important for your fingerprints. You also have apocrine glands, and apocrine glands secrete pheromones and other organic materials. That's usually only in the armpit region and the pubic region. Then you also have sebaceous glands, and sebaceous glands release oils or fatty substances. So for the sweat glands, it's the inorganic and the organic compounds, especially the organic compounds, or really either, that we test for in a fingerprint, and that's part of what shows up and actually develops and makes the print. So, developing the print. It requires, in order to develop the print, it requires that the secretions that were left by the finger interact with the substance that caused that print to stand out against the background. So it may be necessary to use a couple of different techniques. And we are going to use 3 or 4 of these in class. The most common kind that you see is a powder. So a lot of times at the actual crime scene, you'll see them powdering and lifting with tape in order to get an impression of the print. So powders adhere both to the water and the fatty acid deposits, and this is part of what you're going to need to know about latent printing, is what is it in the fingerprint that particular chemical attracts to that allows you to pull a latent print. So for powders, they adhere to both the water and the fatty deposits. And usually you choose a color that contrasts the background. So for example, our lab tables, using black powder would not be real efficient on the lab tables because you're going to have a hard time seeing it. So we also have fluorescent powders that you could use. Iodine, which you've all seen, which has kind of that orangish brown color, can react with oils and fats. So if you have like a piece of paper or something that is a little more porous, iodine, if you leave the crystals there, will release a fume or gas, and that will temporarily produce a yellow or brown color. The problem with iodine fingerprints is that they don't last a long period of time. Anhydrine is a compound that reacts with amino acids. So amino acids are released by your fingers. Amino acids are the building blocks of proteins. So we have anhydrine, and if you have it on like a porous surface like paper, you can spray the anhydrine on there, and it produces a purple color or a purple impression of the fingerprint. There's also silver nitrate, and silver nitrate reacts with the chloride in your fingers to create silver chloride, so it turns gray when it is exposed to light. And then there is cyanoacrylate, which is superglue, and when you put superglue and you heat it, it releases fumes, and those fumes react with water and other things in the fingerprint to form a hard whitish deposit that you can lift. So in modern labs and criminal investigation, they also use alternative light sources to find the prints. So like lasers, alternative light sources are also used to view it. They were first used by the FBI in 1978, and since lasers can damage the retina of the eye, special protection or glasses has to be used in that instance. So here's a picture of an iodine print. So when you put the iodine crystal in there, if it's on paper, the iodine will become a gas, and it will adhere to the substances that are found in the fingerprint. So just to make sure I'm accurate on this, so it will actually attach the oil and the fats. This is an anhydrine, somewhere if it brings it up here. An anhydrine, remember, is, sorry, my skyward jumped in the middle there. That's the iodine. This is an anhydrine. An anhydrine will turn purple once it is exposed to the amino acids left behind by your fingerprints. To be exact, to better see those prints, we actually iron it. It quickens the process that gives us the color change. Cyanoacrylate is the superglue. We put it in a chamber and we close it and seal it up, and we heat the superglue so that the superglue becomes a gas. It will adhere to the liquids and other materials on the fingerprint. Some other prints that can be used to identify individuals. Lip prints. So there's a lab that we have that we might do later on called Sealed with a Kiss, that you can look at the patterns left by lipstick. Your voice can be measured as far as how you speak. Footprint. Shoe prints. We talked about the fact that there are, there's a bank basically of an FBI bank that keeps record of the bottom of the shoes, the marking patterns, etc. we talked about the fact that some criminals have tried to eliminate their fingerprints, and the issue with that is you have more places than just your fingerprints that have, more than just your fingers that have prints. So, for example, the palm has ridges that can be identified, the base of the fingers do. So even if something is done to the actual fingerprint itself, the person can still be identified. Footprints, they are a common means of identification for infants. When people have asked why, I'm assuming it's because of the fact that babies will put their hands in their mouths and the feet. They're less likely to have any contact with the ink once it's put on there. And as I mentioned once before, a man was actually convicted of suffocating an elderly woman on the basis of an ear print. He had left that on the window, listening to hear and see if the person was there. It matched the suspect's ear. Teeth marks, the same thing. Bite marks are unique. They can be used to identify suspects. If it's the person eats, which you'd be surprised, imprints are placed in the gum and can be, or these imprints were placed in gum and could be matched against crime scenes. So all of those do leave. Other prints, as we get more advanced in technology, your blood vessel patterns can be used for recognition. Biometrics, we all use that on our phone. That can also do measurements of identification. We now use this in conjunction with the AFIS, and that is the FBI's fingerprinting system. So a lot of times they'll use retinal patterns or voice patterns or hand geometry along with the fingerprints. So biometrics can be used to control entry or access for computers or other structures. It can identify a person for security purposes, and it can help to identify theft or social security fraud. So when you're talking about fingerprinting system, the FBI has replaced the original database system, which was the IAFIS, with the next generation identification system. These are automated fingerprints, and they have latent search capabilities. It's electronic storage of the images, and it can exchange fingerprints with more than 18,000 law enforcement agencies, and is only, and other criminal justice partners 24 hours a day, 365 days a year. So they are really trying to coordinate with all of the state as well as local so that all of those get uploaded onto that. They're state-of-the-art biological identification services, and there are over 1 million individual records. So, of course, it doesn't do you any good if the person isn't already in the system, but if they have a record, they can now coordinate and search and find that. So, this week we are going to work on latent prints. Next week we will finish some of that up and look at some of the other type. So this week we'll do the latent prints and talk about it. The following week we will probably start finishing up on fingerprints and start doing the fingerprinting for the Maddie case.